Hello, English learners. Welcome to Learning English Through Story. Let's. Today, we'll explore the amazing life of Albert Einstein, written specially for graded Level 2 learners. Let's begin. Albert Einstein, A Curious Mind. Chapter 1. Early Sparks of Curiosity, 1879 to 1894. Albert Einstein was born in 1879 in Ulm, Germany. He was a quiet child who spoke later than others. His family moved to Munich, where his father ran a small electrical shop. Albert liked math and nature. One day, his father gave him a simple compass. Albert saw the needle move and wondered about invisible forces. This compass made him very curious about science. He did not enjoy strict memorization at school. He preferred to learn by asking questions. Even as a boy, Albert wanted to understand how things work. This curiosity guided him throughout his life. Chapter 2. A Road Less Traveled, 1895 to 1900. Albert's family moved to Italy for better opportunities. He stayed in Munich briefly, but felt unhappy at his strict school. Soon, he joined his parents in Italy. There, he studied on his own, reading books about physics and math. In 1895, Albert went to Switzerland, where he found a kinder school in Aarau. Teachers encouraged creative thinking instead of memorizing facts. Albert worked hard to pass the entrance exams for the Swiss Federal Polytechnic, ETH Zurich. He struggled with some subjects but excelled at math and physics. In 1896, he entered ETH. He was free to explore big ideas. Chapter 3. Love, Friendship, and the Patent Office Years, 1901 to 1905. After finishing his studies, Albert had trouble finding a teaching job. He sometimes worked as a tutor and had little money. During this time, he became close to Mileva Mari, a fellow physics student. They shared a deep interest in science. In 1902, Albert got a stable job at the patent office in Bern, Switzerland. He reviewed new inventions and also developed his own ideas in physics. He formed a study group with two friends, calling it the Olympia Academy. They read books and debated many topics. In 1905, Albert wrote 4 important papers, changing modern physics forever. Chapter 4. A New Vision of Time and Space, 1906 to 1911. Albert's papers in 1905 made him famous among scientists. He explained the photoelectric effect, the behavior of atoms, and introduced special relativity. Still, he worked at the patent office until 1909. Then, he became a lecturer at the University of Zurich. He kept asking bigger questions. Could gravity also follow new rules? In 1911, Albert moved to Prague. There, he studied how light might bend near a massive object like the sun. He believed space and time could curve. This idea was very different from Isaac Newton's theory. Albert wanted to test these thoughts with real observations. Chapter 5. General Relativity Takes Shape, 1912 to 1915. In 1912, Albert returned to Zurich as a professor at ETH. He worked with mathematician Marcel Grossmann to find the right math for curved space. In 1914, Albert moved to Berlin. There, he joined the Prussian Academy of Sciences. Berlin was a top place for research but was also tense politically. Albert focused on gravity, trying to show that mass bends space and time. By late 1915, he completed the field equations of general relativity. This theory replaced Newton's idea of gravity with a new vision of curved spacetime. The world was at war, but Albert kept working steadily. Chapter 6. Turbulence, Triumph, and Transformation, 1916 to 1920. World War I caused deep suffering in Europe. Albert opposed the war, which angered some people in Germany. He continued his research in Berlin, even as his marriage to Mileva ended in 1919. That same year, scientists tested his theory during a solar eclipse. They measured starlight bending near the sun, matching Albert's predictions. Newspapers around the world announced that Einstein's ideas changed physics. Suddenly, he was famous outside the scientific community. Despite personal struggles, Albert's success with general relativity brought him global recognition. He felt uneasy with fame, but many admired his brilliant mind. Chapter 7. The Reluctant Celebrity, 1921 to 1925. After the eclipse results, Albert traveled widely to give lectures. He visited the United States, Japan, and other places. Crowds wanted to see the man who bent light. In 1921, he won the Nobel Prize in Physics, but for his photoelectric effect work rather than relativity. Though he enjoyed meeting other scientists, he disliked media attention. Reports about his messy hair and simple clothes followed him everywhere. Albert also debated quantum mechanics with Niels Bohr. He did not accept the idea that nature is random. He thought deeper rules might exist. Despite worries, Albert stayed kind and open-minded. Chapter 8. Confronting Challenges and Ideologies, 1926 to 1933. During the late 1920s, quantum theory grew stronger. Albert admired its discoveries but believed something was missing. He felt uneasy about random events in physics, saying, "God does not play dice." Meanwhile, Germany's social situation became dangerous. Adolf Hitler and the Nazi Party rose to power, targeting Jewish people and opposing Jewish physics. Albert, who was Jewish and a pacifist, faced threats. In 1932, he left Germany for a visit to the United States. Soon after, Hitler took control. Albert decided not to return. He resigned from scientific posts in Germany and became an exile. Chapter 9. Princeton Years and the Search for Unity, 1934 to 1945. Albert settled in Princeton, New Jersey, at the Institute for Advanced Study. He found a quiet place to work. Many refugees from Nazi Europe also joined him there. Albert wanted to unify physics, trying to connect gravity with electromagnetism in one theory. He wrote papers on this idea, but most physicists focused on quantum mechanics. During World War II, Albert warned the U.S. about Nazi atomic research. This led to the Manhattan Project. After the war, he felt sadness about nuclear bombs. He spoke for peace and global cooperation. He hoped humanity would learn from the horrors of war. Chapter 10. Legacy and Lasting Imprint, 1946 to 1955. After the war, Albert kept searching for a unified field theory. He believed nature had a hidden order. He never found a final solution, but he never stopped trying. He also used his fame to talk about world peace. He felt that nuclear weapons were very dangerous. Albert stayed in Princeton until the end of his life. In his final years, he walked and played violin, talking with students and friends. In 1955, he passed away calmly. Scientists and the public mourned him deeply. His name became a symbol of genius and curiosity. Even now, his ideas shape modern physics. Now let's look at the key vocabulary from today's story. I'll give you each word with an example sentence to help you understand how to use it. Chapter 1. Compass, a tool used to find direction with a needle pointing north. Albert's curiosity grew when he saw the compass needle move mysteriously. Curiosity, a strong desire to learn or know something. His curiosity about invisible forces led him to explore science. Invisible, something that cannot be seen. Albert wondered how invisible forces could move the needle. Memorization. Learning by remembering facts without understanding. Albert disliked strict memorization in school. Nature. The physical world, including plants, animals, and forces. Albert loved learning about nature from a young age. Wonder. To feel amazement or to ask questions about something. The moving needle made Albert wonder about the mysteries of science. Strict. Following rules or discipline tightly. Albert found the strict rules at school difficult to follow. Question. To ask or think about something. Even as a child, Albert loved to question how things work. Guide. To lead or influence someone. Albert's curiosity guided him throughout his life. Chapter 2. Opportunity. A chance to improve or succeed. Albert's family moved to Italy for better opportunities. Encourage. To give support or confidence. Teachers in Switzerland encouraged Albert's creative thinking. Creative. Using imagination to create something new. Albert excelled in schools that valued creative thinking. Explore. To look into or study something deeply. He loved to explore big ideas in math and physics. Physics. The study of matter, energy, and how they interact. Albert's favorite subject was physics. Exam. A formal test of knowledge or skills. Albert worked hard to pass the entrance exam for ETH Zurich. Struggle. To have difficulty doing something. Albert struggled with some subjects but excelled in others. Excel. To do very well at something. He excelled at solving difficult math problems. Entrance. The act of entering a place or institution. He celebrated his entrance to the Polytechnic in Zurich. Chapter 3. Stable, steady, and unchanging. Albert found a stable job at the patent office. Tutor. Someone who teaches one-on-one. Albert worked as a tutor while looking for a permanent job. Invention. A new device or idea created by someone. Albert reviewed inventions as part of his job. Debate. A discussion with different opinions. The Olympia Academy often debated scientific topics. Academy. A place or group for education and learning. Albert formed the Olympia Academy with his friends. Paper. A written document about research or ideas. Albert's 1905 papers changed modern physics. Develop. To create or improve something. He developed important theories during his spare time. Topic. The subject of a discussion or study. The group discussed topics ranging from philosophy to physics. Physics. The study of natural laws and forces. His passion for physics drove his groundbreaking ideas. Chapter 4. Relativity. A scientific theory about time, space, and motion. Albert's theory of relativity changed how people understood the universe. Observation. Watching or studying something carefully. Albert wanted to test his theories through real observations. Behavior. The way something acts or functions. He studied the behavior of light near massive objects. Massive, very large or heavy. He believed light would bend near a massive object like the sun. Gravity, the force that pulls objects toward each other. Albert asked if gravity followed the same rules as other forces. Theory, an explanation of how something works based on evidence. Albert's theory of curved spacetime challenged Newton's ideas. Curve, to bend or change direction. He suggested that space and time could curve around massive objects. Explain. To make something clear or understandable. His papers explained complex ideas in simple terms. Famous. Albert became famous among scientists for his groundbreaking work. Chapter 5. Equation. A mathematical statement that shows two things are equal. Albert worked hard to complete the field equations for general relativity. Academy. An institution for advanced learning or research. Albert joined the Prussian Academy of Sciences in Berlin. Mathematician. A person who studies or works with math. Marcel Grossman helped Albert with the math for his theory. Replace. To take the place of something else. His theory replaced Newton's idea of gravity with curved spacetime. Spacetime. The combination of space and time as one concept. Albert showed that spacetime is affected by mass and energy. Field. An area of study or research. He developed new ideas in the field of theoretical physics. Mass. The amount of matter in an object. Albert believed that mass could bend space and time. Vision. An idea or plan for the future. His vision of curved spacetime was revolutionary. Steady. Continuing without stopping or slowing down. Albert worked steadily, even during the political tensions in Berlin. Chapter 6. Turbulence. A state of conflict or disorder. Albert's life was full of turbulence during World War I. Oppose. To be against something. Albert openly opposed the war, which upset many people in Germany. Prediction. A statement about what will happen in the future. Recognition. Being acknowledged or admired for something. Albert gained global recognition for his general relativity theory. Success. Achieving a goal or result. Despite personal struggles, Albert found great success in his work. Fame. The state of being well known. Newspapers made Albert famous beyond the scientific community. Eclipse. When one celestial body blocks another, such as the Sunday. Scientists used a solar eclipse to test Albert's theory. Brilliant. Very intelligent or talented. People admired Albert for his brilliant mind. Struggle. A difficult or challenging time. Albert struggled with personal and professional challenges during the war. Chapter 7. Celebrity. A famous person. Albert became an international celebrity after winning the Nobel Prize. Lecture. A talk given to teach or explain something. He traveled the world to give lectures about his theories. Prize. An award for achievement. Albert won the Nobel Prize for his work on the photoelectric effect. Media. Channels of communication, like newspapers or radio. The media focused on Albert's messy hair and simple clothes. Attention. Interest or focus from others. Albert disliked the constant attention from reporters. Debate. A formal discussion on different opinions. He debated quantum mechanics with Niels Bohr. Random. Without a specific pattern or purpose. Albert disagreed with the idea that events in physics were random. Rules, principles, or laws that guide actions. He believed deeper rules might explain the universe. Open-minded, willing to consider new ideas. Despite disagreements, Albert stayed open-minded during debates. Chapter 8. Ideology. A set of ideas or beliefs. Albert opposed the dangerous ideology of the Nazi Party. Uneasy, feeling worried or uncomfortable. He felt uneasy about the rise of Adolf Hitler in Germany. Threat. A danger or warning of harm. Albert faced threats because of his Jewish heritage. Refugee, a person who leaves their home to escape danger. Albert became a refugee after fleeing Nazi Germany. Exile, being forced to live away from one's home country. Albert lived in exile in the United States after 1933. Racism, discrimination based on race. Albert opposed racism and spoke out against injustice. Rise, to grow in power or influence. The Nazi Party's rise to power made Germany unsafe for Albert. Pacifist, a person who believes in peace and opposes violence. Albert's pacifist beliefs angered some people in Germany. Dangerous, likely to cause harm. Albert knew it was dangerous to stay in Germany. Chapter 9. Institute, an organization for advanced study or research. Albert joined the Institute for Advanced Study in Princeton. Refugee, a person who escapes their country due to danger. Many refugees from Europe joined Albert in Princeton. Unify, to bring together or combine into one. Albert tried to unify gravity and electromagnetism in one theory. Electromagnetism, the interaction between electric and magnetic forces. Albert hoped to connect gravity with electromagnetism. Atomic, related to the smallest unit of matter. Albert warned the U.S. about Nazi atomic research during the war. Project, a planned effort to achieve a specific goal. His warning led to the Manhattan Project to develop nuclear weapons. Cooperation, working together to achieve a goal. Albert believed in global cooperation after the war. Horror, a feeling of great fear or shock. He felt horror at the destruction caused by nuclear bombs. Sadness, a feeling of unhappiness or sorrow. Albert expressed sadness about the use of atomic weapons in war. Chapter 10. Legacy, something left behind after a person's death. Albert's legacy continues to inspire scientists today. Hidden, not visible or obvious. He believed nature had hidden rules waiting to be discovered. Solution, an answer to a problem. Albert never found a final solution to unify physics. Dangerous, likely to cause harm or damage. Albert warned about the dangerous effects of nuclear weapons. Fame, being widely known or recognized. Albert used his fame to speak about world peace. Mourn, to feel or show sadness after someone's death. Scientists and the public mourned Albert deeply when he passed away. Symbol, a person or thing that represents an idea. Albert's name became a symbol of genius and curiosity. Shape, to influence or form something. His ideas continue to shape modern physics. Curiosity, a strong desire to know or learn. Albert's endless curiosity guided his lifelong search for knowledge. That's all for today. Thanks for learning English with us. If you'd like to read along, you can find the PDF version of this story in the link below. Don't forget to subscribe to join us for more English learning stories. See you next time.